Alright, so I'm in the second phase of testing. My diaphragms both were ripped immediately on the last try. As you can see, this one had a ripper on the edge, the other one had rips all over it. So I'm trying again. I did a double layer this time, and I will have to say I do not like using latex for the diaphragm. One reason I built this to its dimensions was to make an easily interchangeable diaphragm, because I knew they were going to rip. And even though I'm using tape right now, this pretty much substitutes as a flange, which is really needed for a commercial type model if you wanted to build something like this. Alright, now we'll go into a more advanced stage of testing. I think the hot water didn't work for me. So I'm starting out with about 67 degrees. I'm going to heat down here and see what happens, and I'll record the results. Okay, so I could tell on this one that after careful sanding around the rims here, that I am holding pressure. You can see it bouncing back up slowly. So that means that I do have a good seal, and my diaphragms aren't ripped yet. Finally, a little bit of success with this device. I'm very happy. It's hard to do this and hold the camera, but I'll try and do it in the next clip. Okay, so here's my conclusions on this. Simi 112, who I took one of his schematics to build this, has an excellent thing going. I did get it working, but the oscillations were so small that I couldn't see doing anything with it. I mean, the device is fantastic. It does work, and I was getting small oscillations that were very hard to see here. And by piling up pots and books and stuff to videotape it, it was really hard to show. But I'm already going to move on and go back to the same schematic that I used for this model, but I'm going with all 1-inch pipe here. I think that Simi 112's standing wave idea needs the full flow to work and get the better oscillations up here. All in all, I designed this one. I tried to make this loop compensate for the volume aspect by toning it down. By heating on that smaller diameter, I think that it made the oscillations smaller. I think with a full-size pipe it'll work better. Also, working with copper, my heat measurements were not good on my IR detector, and I had a black spray paint. For some reason, I've noticed on the IR thermometers that shiny metals do not give you an accurate reading. Like here, where you can see my brazing marks, if I put the laser on there, you get a much better temperature reading. If you put it on the copper, for some reason, it does not give you an accurate temperature reading. And I can say that it's definite because that black spot was showing 75 degrees, and yet I couldn't touch it. It was so hot. So if you're experimenting around and you're using a shiny metal, that's something probably to think about. All in all, I like this device because it really has no moving parts besides the diaphragms. And I built this, and I did give it a lot of thought before I built it, and I watched a lot of videos. But one thing I liked about it is once I had my idea down, I was able to do it pretty quickly. I brazed everything because for me, it's since I braze a lot, it was very easy for me to fabricate all the parts that I needed. the top plate was, I beat the piece of pipe down flat to make this top plate. And my next model, I'm working on some parts. I have to buy a T, and I'm going to solder instead of braze, so that if I want to reconfigure, I can do it easily. I can just sweat the fittings apart. So I won't be brazing on the next one so much, but I will be probably scrapping this model to use my diaphragm chambers. Also, another problem, which is probably the main problem with this device, is this sharp edge. Now, I sanded that down really finely, but the latex diaphragms will not work like that. They rip before I can even get any real testing going. Even this one, I sanded really well, but after I got the oscillations going, it ripped on the corner almost immediately. It didn't help that my magnets have metal shards stuck to them, and getting the metal shards off of magnets is not really that easy. That may be something for a whole nother video, with all I tried to clean these magnets up. So little metal flakes were cutting into here and making holes too. But all in all, I think this is a very interesting device because of the moving parts being just the two diaphragms. On a final note, the weakness of this device is the fact of using latex. For a good model, I need to think of something else that you can get the proper flexibility, but yet can withstand some heat and some torture. So I'm going to go ahead on to version 2 with all 1-inch pipe through here. I'll cut all this off. And now that I know it works, and it's generally forgiving on your volume requirements, and I thought that the free piston build that I was working on, a big problem that I'm having with it is building the piston and making that work. Blade Attila's video, it's so easy yet so hard. But I think once you, as a builder myself, a lot of the math on this stuff I can't do, but as a builder, I know how to do and make things quickly and what's efficient. So this was a good design, and I also did this to work in a pan of hot water. That was a big key point of this. So I'll be changing the design around a lot, but this is definitely a winner. It does work, and I suggest checking out Blade Attila's channel and Simi 112. These guys obviously have it going on. All right, everybody. I'll be as soon as I get my tea, I will be doing the next version, which I'll call version 2.